discuss our new software. It is called EnigmaQ Geotrust. This software is based on merging the quantum principles, some quantum principles with geophysical and geological analysis techniques. Unfortunately, we have some poor link between quantum principles and the geological and geophysical analysis. But this software is based on using quantum circuits to make some advances in the geological and geophysical analysis. As you see here, we have two pipelines. At the top, the pipeline, all of these menu are based on a pipeline for image processing, remote sensing image processing and analysis, and merging with geophysical processing. For the left tree pipeline, we have some tools based on or a pipeline for geological modeling and merging with geophysical. So we are based on two major pipelines. The pipelines shown at the top containing different menus for remote sensing, image processing, and analysis, and the pipeline represented by the tools on the left panel, which is for geological modeling and merging with geophysical data. Okay, so let us see. First, we create a project folder, for example, on desktop, just a new folder, and make it okay. Make it, for example, Enigma or any name, Enigma test. Okay. This will be our folder. Okay, it is empty right now. Now we bring some test data. We have a copy of test data. I think we have some copy here of test data.
Hello?
Yeah, hello. Hello, Dr. Martin. You hear my voice?
Yes.
Okay. This is a copy of test data. So let us open it. You have a test data for remote sensing. Just and a test data for just I will delete this. This was from previous tests. So just I delete the previous test. Now, the geological modeling test data contains a column Excel file. This is a column Excel file. Just opening the Cola Excel file now. This is the Cola Excel file. Okay, this is our Cola Excel file. It contains the whole ID, X, Y, Z, and the maximum depths for each hole. Let us see the survey file. It contains the whole ID, depth, dip, and azimuth. Okay, and the lithology file. Contains the whole ID and the top and the bottom and the lithology for the interval and if you have veins. So for the geological modeling data, you must have the three files with the same format and structure of data. This is just a satellite image or also photo, and this is a topographic. This is a topographic data. Okay, so this is the remote sensing, sorry, this is the geological modeling test data. We have geophysical data containing synthetic conductivity map and the synthetic gravity. This is a grid or gravity grid and magnetic grid and resistivity grid. So this is our test data that we will use, the geophysical data containing synthetic conductivity and the synthetic resistivity and magnetic and gravity. This is the geophysical. For geological modeling, we have the drill holes containing a collar lithology survey. We must follow the same format of the three files and containing the satellite image here and topo ask is a topography file. For remote sensing, we have some samples of satellite image data. So we copy all of this folder to our project folder. This is our project folder. Okay, now we
Excuse
have,
me.
yeah, you are also welcome. This is a remote sensing sample. This is the geological modeling, the drill holes, the three Excel files for drill holes, the satellite image and topo ask. And the remote sensing is the samples of satellite images, and geophysical is two sections for resistivity and conductivity, and the two grids for magnetic and gravity. Yeah, you also welcome.
Uh, yeah, excuse me. From the demo data I have, I don't see the folder of the geological modeling. It's just geophysical and remote sensing.
Yeah, you have the copy before geological modeling. So you don't, I think you don't have the copy, the new copy after geological modeling.
Yeah.
You have only the copy containing the top menus that includes file, GPS settings, pre-processing and them display, hydro and spectral, terrains and 3D, drill, geophysics, modeling display, advanced classification, band, signature, geo artificial intelligence, and hybrid, right? You don't have the left panel containing whole color survey,
No,
okay, right?
no, yeah. I don't
Okay.
have.
So just this was the previous, and this is the previous version of software. Okay, we
Okay.
didn't upload the new version yet to the drive. This
Okay.
is the new version. Okay, so
Okay.
your data just contains geophysical and remote sensing,
Yeah.
not geological model. Okay, let us
Yeah.
start by describing our software. We have two main pipelines. The pipeline for remote sensing image analysis and processing and merging with geophysical. And the left panel is for geological modeling and merging with geophysical. So the software EnigmaQ Geotrust is based on merging between quantum physics principles with geophysical and geological analysis tools to
Mm.
increase the accuracy and increase the analysis, the target identification. Just before starting, we must be careful that applying quantum principles have advantage and also have disadvantage. It can make some amplification of the signature, but at the same time, it can make amplification of the noise as well. So each technique will have some side effects. It amplifies identification of signals, but at the same time, it amplifies also noise. So you must have a strong filters to remove the noise. Okay. So let us start. First, we describe the user interface of our software. The file menu, including import and the output folder. This is to define new output folder and a PDF report. GPS, including if your satellite image or map doesn't have coordinate, so you just have to set the coordinate manually by selecting set coordinate just to enter the minimum x, maximum x, minimum y, and maximum y, minimum z, and maximum z, or in terms of latitude and longitude, the minimum longitude, maximum longitude, minimum and maximum latitude, and z minimum and z maximum. But if your image have its coordinate, or if it is geo-referenced, the software automatically read its geo-reference system from the view GIS metadata. This will read the image GIS metadata if it is containing a metadata for GIS. The third menu is including the settings for quantum circuits, the threshold for gold identification, threshold for diamond, threshold for copper, a threshold for water, a threshold for graphite, and the machine learning PPI settings. For example, the gold threshold, you must enter the threshold or just to apply the minimum probability to give to the quantum circuit to finding gold. So, for example, if you set 0.35, it will set the threshold to 35%. So this means it will search within the satellite image or the map for the probability of gold signatures starting from 35% to 100%. If you set it to 0.55, for example, it will start searching for probability starting from 55% to 100% and so on. And also you have the same, you have to set the same settings for the other circuits, the diamond threshold, the copper threshold, the water threshold, the graphite threshold, and here we have the machine learning settings. This is for the RF estimators, the k-means clusters, and the number of iterations, and the ratio of the vertical axis to the horizontal axis, x and y. This is for the DEM, representing the DEM or digital elevation model, and also extracting synthetic DEMs from the analysis of the image itself. Then we have this menu. This menu is responsible for pre-processing for image processing, radiometric correction, atmospheric correction, terrain illumination correction, contrast enhancement, adaptive histogram, and we have three types of noise reduction: bilateral filter, non-local means, Gaussian adaptive, edge enhancement, and also display the corrected geometric, the normalized topographic and the multi-hillside, and the synthetic proxy digital elevation model. This is created during the processing of the image itself, or to import external digital elevation model. This will be a real digital elevation model, not a synthetic one that is created during the image processing. The display is important menu. You have to display the corrected image, the structure, the NDVI for vegetation, the vegetation mask, fingerprints for gold, diamond, copper, groundwater, graphite. These are quantum fingerprints. The overlay of gold, diamond, copper, groundwater, and graphite, or a specific other mineral that you choose, and the integrated for gold, diamond, copper, groundwater, and graphite. This is integration maps between the structures and the signatures, the quantum signatures for the minerals. And finally, the combined mineral distribution map. For the HIDO menu, you have HIDO, MNF, and BBI, unmixing and band math. For terrain and 3D lineament map, density, this is lineament density map, 3D depth map, 3D point cloud, and 3D data, or the terrain viewer, geological intelligence modeling. The drill containing gold, diamond, copper, groundwater, graphite, and the ranking for gold, diamond, copper, groundwater, or graphite, or to export a KMZ file for Google Earth. Geophysical is important menu containing importing geophysical data or filters, different filters for geophysics. For example, separation filters for magnetic and gravity, separation of regional anomaly, residual anomaly, edge depth filters for magnetic and gravity, upward continuation, first vertical derivative, second vertical derivative, tilt derivative, specific magnetic filters, including reduction to single pole, analytic signal, radiometric analysis, including uranium to potassium ratio, sodium to potassium ratio, uranium to thorium ratio, or the potassium map, sodium map, uranium or total gamma ray count. We have a menu for modeling geophysics, modeling magnetic gravity, resistivity, conductivity, radiometric. And for radiometric, you have total gamma, potassium, thorium, or uranium, integrating between geophysical maps and sections with the analysis of the remote sensing data, including integrating magnetic, gravity, resistivity, conductivity, or radiometric. Display the integrated map for locating gold, locating diamond, copper, graphite, or water. And this button is to reset all the processed data to the raw data. If you have mistakes in choosing filters or the settings of certain filter, you could reset to the raw data itself. Modeling display, including to view the 2D cross sections, view depth slices, or a 3D viewer for magnetic, gravity, resistivity, conductivity, and radiometric. Advanced to import real digital elevation model or to apply atmospheric correction. Classification including, this is image classification, including unsupervised and supervised classification. The bands of the satellite image, including to view the red band, the green band, the blue band, infrared band. If the image doesn't contain a real infrared band, so it will create a synthetic infrared band itself. And also to view the NDVI for vegetation, the clay ratio, the iron ratio. This is important menu for extracting a signature for a new mineral. If you are looking for a new mineral, other than gold, other than these minerals, gold, copper, diamond, water, graphite. So you have to set manually the signature from the satellite image. And so the software will look for this new mineral. And also to select the active signature and to run the total pipeline for this mineral. Geo AI, including the NDPI, slope, classic anomaly, and hybrid, including the quantum classic prospectivity. This is the tools for the pipeline for image processing, remote sensing image processing, and geophysical analysis and merging between both techniques. And also you have the import to import your image output to run the pipeline to view the gold overlay, diamond overlay, copper, water, graphite, and the final report. For the left panel, we have a new panel for geological modeling, including to import the boreholes, including Kohler, survey, lithology, and the grid files, or display the 3D boreholes. We have GIS data to import satellite image, map, and the vector or shape file. Importing geophysical data to merge it with the geological modeling, including magnetic. We have different types of magnetic data to import a grid or map or cross-section, 3D model, or Excel data. Also for gravity, you have different options for the data, grid, cross-section, 3D model, and Excel, radiometric, resistivity. And we have a new tool for importing seismic SIG-Y data or load seismic map or seismic cube. Then you have topography to import the digital elevation model or to set the project boundary. We have the 3D quantum models to create 3D project, to create deposit or erosion or vein system, fault, stratigraphic sequence, fault or intrusion, and the output volume. This is to make cross-section slice, and for the mesh, to build mesh or import mesh or edit mesh. Kriging tools for ordinary kriging, simple kriging, universal kriging, indicator kriging, and co-kriging. and the junctive kriging. For geostatistical analysis, you have biography, Gaussian simulation, indicator simulation, E-type map, probability map. Block modeling, we have create block model, grid estimation, resource classification, and finally edit surface to edit deposit, edit vein, or edit fault, or edit intrusion or fault. This is overview of the user interface of EnigmaQ Geotrust software tool. You have any problems in the user interface, please? You have any problems in the user interface? Okay. First, we import our satellite image. We look for our project folder. This is our project folder. We open the remote sensing test data. Let us select this image, for example, as a satellite image and open. Okay, you see this satellite image, please. Okay.
Yes.
Okay, so this image has only three bands, the green, blue, and red bands. It doesn't contain infrared band. Let us see the bands of this image. From band, you could see the red band here. Okay, this is the red band. The red pixels show the pixels that reflect in the red spectrum band, and the black represent the pixels that doesn't reflect in within the red band. Okay, the black represents the pixels that doesn't show any reflections within the red band. Let us see the green band. Again, the black represent pixels with no reflectance within the green band, while the green pixels represent the pixels that reflect within this band. So moving to the blue band, we have also the black representing the pixels with no reflections within the blue band, while the blue represents the pixels with reflections within this band. For also the synthetic, this is a synthetic infrared band. Again, this is if the image doesn't contain an infrared band, it will synthesize a synthetic infrared to run the pipeline analysis. And also you have the NDVI for vegetation. Okay, you could see this is the NDVI for vegetation and also the clay ratio. This is an image of the clay ratio. This is an image of the clay ratio. Just a minute. This is the image of the clay ratio and the iron ratio here. This is the clay ratio and this is the iron ratio here. Okay, let us start our analysis. First, if your image is a real aster or Landsat image, you should apply radiometric correction, atmospheric correction, terrain illumination correction, contrast enhancement, adaptive histogram, or some noise reduction tools like bilateral filter, non-local means, or Gaussian adaptive, and edge enhancement. But since our this image here is not a real, it doesn't contain all the 7 bands for Landsat or all the bands for Aster, so we could skip these pre-processing tools. But after processing, I will show the effects of these tools on this test image. So we could start the processing. We first, since the image doesn't contain metadata for GIS, we have to set the metadata manual. Either to set the X in terms of universal transverse Mercator system, the minimum X and the maximum X, minimum Y and maximum Y, minimum Z and maximum Z, or in terms of latitude and longitude. Let us, for example, make it in terms of universal transverse Mercator. I will set here, for example, the minimum X as 1000 or maximum X as for example 15,000. Okay, minimum Y, you could set 700 and to 3,500. Minimum Z, we could set it ranging from 100 meter to 1 kilometer above the sea level, and click OK. Now you have to go to review the GIS metadata. You will see the X and Y for the corners according to the values that we have entered. This is the X and Y for the 4 corners of the image now. And click OK. If you accept this, you have to click OK. Now we start running the pipeline. Just click on Run Pipeline. It will run a complete pipeline involving 22 analysis step. Just click on Run. Before running pipeline, you have to set the output folder. We select our folder Enigma test as output, and just click on Run Pipeline. And wait until it finish running the pipeline. It is step, if you look at the bottom corner, at the bottom left corner, it is now in step 10, which is subpixel mineral mapping. You will see it on the bottom left corner. At the bottom, it is now in step 10 from 22 steps of analysis. We have to wait until it finish all steps. Now it is step 11, Geo AI, and step 12, structure and linear extraction, the band mass, and step just step 15 takes some long time. Step 15 will be for creating quantum signatures for the minerals. and also creating the overlay and integration maps. So it takes some long time. Step 15. Let us review the output of the previous steps. We could see, for example, the geometric corrected, the topographic normalized, just because we have done it 2 times, the multi-hill shade, to view the proxy digital elevation model. This is a proxy or synthetic model showing the relative elevation. This is a synthetic model created from the image since we didn't upload a real digital elevation model, but you have the option to import your real DEM model from the menu from here to import the real digital elevation model here. Now you have also this is the corrected the structure. This is the structure, original structure. Okay, let us see this is the journal NDVI and the mask for vegetation because we have to make a mask for vegetation before extracting the quantum fingerprints for the different minerals. You could show now the quantum fingerprint for gold. You see now the quantum fingerprint for gold. So the dark brown areas are areas with high probability of finding gold, and the red, according to the scale, the white will show the areas with no probability of finding gold. You see well the differentiation between the areas with high probability of finding gold and the areas with no probability of finding gold. Okay, you see it? Okay.
Yes, yes.
Now
Yes.
we could display the map for another mineral. This is the gold. We could display the fingerprint for diamond. Again, here, according to the ligand, the color ligand, you have the pilot, the pink areas representing some probability of finding the kimberlite, which is associated with diamond. Here, the quantum signature is looking for structure environments for deposition of kimberlite or for association of kimberlite, which is a good indicator of the diamond. We could see the fingerprint for copper. Again, you see at the bottom, you have the dark brown areas for finding copper at the bottom of the image. You could see also the fingerprint for groundwater. Here in the central top, And also extending to the bottom, you have some blue, dark blue, representing water quantum signatures on our satellite image. Also, we have fingerprint of graphite. We have only a single zone at the top, which is colored by black. This zone is only the zone for finding graphite within this satellite image. Also, you could see the overlay of gold. Now you have some reduction of the gold probability, and also you could see the overlay for diamond, the overlay for copper, the overlay for groundwater, and to display the overlay of graphite. Only you have the zone at the top, but here actually I could see that we have no areas with dark gray. We are looking for dark gray according to the color scale here. You could see the color scale. We have to look for dark gray areas. Also, you could see the integrated between the structure and the quantum signature for gold, and for integrated for diamond, and integrated for copper, and integrated for groundwater. You could see here the fractures or lineaments across the groundwater signature, and also integration for graphite. Also, you could show a combined mineral wealth map. This mineral wealth map is based on quantum signatures. It will take the higher probability for finding a certain mineral within each pixel. So each pixel is colored only according to the mineral with higher probability, higher relative probability. So for example, the yellow pixels, according to the legend at the bottom, yellow pixels means that gold have higher probability at these locations than the other minerals. There will be a higher probability for gold relative to the other four targets, which are copper, diamond, graphite, and groundwater. And red will show the pixels with higher probability of finding copper relative to the other minerals. Blue representing pixels with higher probability of finding groundwater. And the light green here representing for diamond, and actually we only have this zone, this narrow zone at the top is the zone for relative higher probability of finding graphite. So this is the quantum probability of finding different targets from the 5 targets. So this is for display. If you select a new mineral, you could display the fingerprint of this new mineral. You just select it from here, from signature here. Just select extract and view signature, and click OK. It will open the original map. Just drag by your mouse to select a certain signature for a new mineral. For example, if we select this zone and click enter, it shows the spectral information for this zone, and click OK, and you could add this new mineral for the pipeline. You just click yes, and just enter the mineral of mineral, for example, mineral X, and click OK. Now, if you go and also it asks you if you would like to save the spectral data as a CSV. So just select yes or no. This will save it on the output, on the same output folder here. Then you could go to signature and select the active signature. You could see the default signatures, which are the signatures for diamond, gold, copper, water, and graphite. And if you open the menu, you will find your new mineral that you have selected, which is mineral X. You could select whether to select X or the default minerals. If you select X, it will run the complete pipeline for both of the default signatures for copper, gold, diamond, water, and graphite, and also in addition to the mineral X. And you could see the results for the new mineral X from the display. You have the fingerprint for other, which will show the fingerprint of the X minerals that we have selected, and also the overlay for other, and the integrated for other. Okay. Also, you have this is a Haidu. This is Haidu channels and the MNF and the BBI and also the band mass, the iron oxide band mass and the clay mineral band mass. And you could see the lineament. This is the extraction of lineament from the satellite image. And also the lineament density. This is a lineament density map. The 3D depth map and the 3D terrain viewer, which shows the synthetic digital elevation model. If you select this, you could show the synthetic digital elevation model. Okay. So you see now the synthetic digital elevation model, right? You have the color ligand and also the elevation ligand, right?
Yes, yes.
Okay.
Yes.
So this is a synthetic digital elevation model. Also, you have option for here. If you select the 3D geological intelligence model, it will show a synthetic 3D geological model. Here, it will be the same like the digital elevation model because you didn't enter boreholes or didn't enter additional data. So it will look similar to the digital elevation model. Now we have an important view of the base locations for drilling for gold and for drilling for diamond, for drilling for copper, drilling for groundwater, and for graphite. And just the most important is the rank map. This is a map for ranking gold priority. You could see a high priority is areas with red color, and green is low to zero priority. So you could search for the areas only colored with red means the high priority of finding gold. Also, you could show the ranking diamond. This is also the base locations for high priority according to the quantum signature analysis of the satellite image only. And ranking copper, you have only some small areas at the bottom with priority for copper and some narrow areas at the top for copper. Also for ranking groundwater. Okay, now you have some high probability or high priority in this zone for high priority for groundwater. Also for graphite, you see only another zone at the top corner with red, which is high priority for graphite. And also you have option to export to Google Earth. Now, important tool, but before this important menu, we go to classification. This is the image classification, the unsupervised classification here, and also the supervised classification. You could see the supervised classification here. Also, you have the option for Geo AI for vegetation and for slope and for classical anomaly and quantum classical perspective. Just take care to run only the pipeline for one single time, because if you run for 2 times, it will result in some mistakes in defining the slope and the classical anomaly. So you must be sure for running the pipeline only, click on pipeline for single time, for only one time. We have tools for geophysical. We import our geophysical test data. We have this is our test data. You could import a single type of data or all types of data. So I will import all types of data. Now we have imported synthetic conductivity and synthetic gravity grid and the magnetic grid and resistivity, and click OK. Now you could make some filters. This is separation filters for magnetic and gravity. For example, to get the residual anomaly or regional anomaly, let us, for example, make the residual anomaly and you select whether it is applied to magnetic or gravity data. For example, if you select the gravity data and click OK, it will apply it to the gravity data. This is the result of the residual application of the residual filter to the gravity anomaly. Now you could also apply some filters for upward continuation. You could apply it for magnetic or gravity. Let us, for example, test for magnetic. This is the upward filter. And also from geophysical, you could apply first vertical derivative or second vertical derivative. This is the second vertical derivative. Okay, and this is tilt derivative. And you have to choose smoothing or sigma. I could make it as the default 3 pixels. Okay, and also you have some filters for magnetic, the reduction to a single pole. And you have to set the date of the survey, the magnetic intensity in nanotesla, magnetic inclination, and the magnetic declination. You could get these values from any IGRF model in the internet. And so it will apply the reduction to pole. Now, since we have made some mistakes in filters, so you have to reset to raw data. But if you accept the filters, you can go on. Just to reset to raw data, it will reset all the filters to the raw data. And so it will be ready for, also you have radiometric radiometric. And you could now integrate with the satellite, integrate the magnetic to use the raw data. Okay, integrate with gravity. You could use the raw data. Integrate with resistivity. You could use the raw data, or integrate with conductivity. Since we don't have here radiometric data in our test data, but if you have radiometric data, you could integrate with radiometric. And then display integrated. This will display the result of integration for locating gold. Now you see we look for only the dark brown area. It has been reduced extremely after integration with the geophysical. Only you have these locations, these very narrow locations at the bottom. Okay, this is we are looking for dark brown and this narrow zone here. And here is a narrow zone also here. So this is after the integration with the geophysical techniques. Also, you could choose a result of integration for other display for diamond. This is also after integrating with diamond. Display for copper. Okay, it has been reduced extremely to only very small zones here with a dark brown. And displays are integrated for graphite. And displays are integrated for groundwater. These zones with blue, with color blue is for water. Also, you have some modeling inversion tools for inversion of magnetic, and you have to select the depths. For example, if you make it 400 meter, it will apply some inversion for the magnetic data and will show the pseudo section for after magnetic inversion. Also, you could model, for example, modeling gravity, and you select the depths and click OK. And this is the result after modeling for gravity and also inversion for resistivity data. You could select the depths and click OK. This will show the inversion for resistivity data. Since we are using the same area for generating some synthetic test data, so it will show approximate similar results here. But if you have real geophysical data, it could show some differences between the inversion results. We could show the inversion of conductivity. This is the modeling. We model conductivity. Yeah, I think I have some problem here. Now you see the results, the output of our analysis. Okay, the 3D depth map, the band mass minerals, the combined minerals, the corrected visual, and drill site for copper, for diamond, for gold, and for graphite, and for groundwater, and the selected spectral signature for X mineral. and the filtered gravity for residual, for magnetic, for the tilt derivative for the magnetic, the copper fingerprint, the diamond fingerprint, the gold fingerprint, and the graphite fingerprint, the groundwater fingerprint. Also the pseudo section for gravity, for resistivity, and the pseudo cross section for magnetic. And you have the integrated gold, integrated diamond, integrated graphite, integrated groundwater, the lineament density, lineament map, MNF transformation, and model conductivity. This is a slice at depth 100, and this is a slice at depth 200. And you have the unsupervised classification, ranking maps for ranking copper, ranking diamond, gold, graphite, groundwater, and the proxy digital elevation model, the overlay for all the minerals or targets, and a PDF for including the important maps for the report. Okay, all of these are the output of our previous analysis. Okay, so you have any problems till now, please? Okay,
Yes, yes.
Oh,
and the folders, these are the folders of our original data. This is the bands that we have extracted for red band, green, blue, and the infrared, and the georeferenced image, the ratio clay, ratio iron, and the NDVI. Okay. This is our original data that we have entered, and this is the geological model. So, do you have any problems for the pipeline for remote sensing image processing and geophysical processing and merging with geophysical? Do you have any problems in this pipeline, please? Okay. Do you have any problems for this pipeline?
no, it's okay.
Okay. Now, after the Zoom break, we have the second pipeline for geological model.
Он так меня достал, и я его догнала. И я хочу теперь такого, как Путин.
Coding. Now, you have option to view the 2D cross-section, either for magnetic gravity, resistivity, or conductivity. For magnetic, for example, and you could see it for gravity, or for resistivity, or for conductivity. Okay, now you have options to view the depth slices for model magnetic, for example, you have different depth slices, depth slice at 100 meter, 200 meter. The step here is set to 100 meters, so it will make depth slices each 100 meter, and also the same for gravity, resistivity, and conductivity. So if you select, for example, at 300 meter and click OK, this will show at 300 meter. And also you have options to show the 3D for magnetic, but it asks to enter your digital elevation model or run the pipeline to create a synthetic one. So just run the pipeline to create a synthetic digital elevation model. You have to wait until the end of the pipeline. Or
Hello.
yeah, do we have a question?
Yes. I see that the software is really user friendly, but is it only for geophysics? It's only a geophysics interface?
It is for remote sensing, geophysics, and geological model.
Or and also geological model?
Yeah, we have the left panel for geological model. Okay.
Okay. Okay.
But
No, that's
honestly, for geological modeling, I will show to you the results for geological modeling. It is not so beautiful or not so smooth like output of Leapfrog, for example. I
okay.
will show to you the results here. But for
Okay.
the most advantage is for remote sensing and geophysical. Okay. Let us
Okay.
see the modeling in 3D for magnetic. Okay. This will open a new window for the 3D overlay of magnetic. You see the difference between the red areas for high magnetic and the blue for low magnetic. And you could see also the 3D for gravity. Okay, this is the 3D for gravity. And the display of model for resistivity. Okay, this is for resistivity. And this is for conductivity. Now, if you have radiometric data, you could also see the models for radiometric for total gamma ray count, potassium, thorium, and uranium. So let us see now about our left panel for geological modeling and integrating with geophysics. So let us import here to this panel the grid of magnetic. Okay, I will make it. You have to change the format to all and to select your magnetic and click OK. Now you see the magnetic grid here. Okay, you see the magnetic grid.
Yes, yes.
Okay, this is a synthetic magnetic grid that we have created. So you could also import grid for gravity. Set it to all files and select the gravity. This is the gravity grid. Okay. You see the gravity grid? Okay. You see the gravity grid? Hello?
Hello?
Yeah, you see the gravity grid here?
Yes, yes, yes.
Okay. Also, you could import cross sections for resistivity. This is synthetic resistivity. Okay. This is the overlap between the cross section and the gravity. Between the cross section for resistivity and the gravity grid. Okay.
Okay.
Also, you could import the conductivity cross section. It is a cross section for conductivity. Okay, this is the conductivity and also the gravity grid. Okay. Now take care if your geophysical data is not on the same georeference like the modeling data. The model will be crashed. So you must be sure that the geophysical data have the same GIS data like the geological modeling data. Let us now start on importing the Cola file. We import the Cola Excel file from modeling. This is Cola. And we import the survey. The survey. Okay, now we import the lithology. This is the lithology. Now this is the lithology. Now we could display the 3D, the boreholes in 3D. Just you have to wait until it loads the window for displaying the boreholes. Okay, you see the build of the boreholes.
Yes, yes.
Okay, just wait until it finish. Just build the boreholes. Just you have to wait until it finish. It just loads building the trajectories for the boreholes and also building the lithological for each borehole. You have to wait until it will finish and show the ligand, and then it will show the ligand at the end.
Okay, okay.
It takes some time only for building this trajectory, and then it will show the ligand at the end. Now it has finished. When you see the ligand, this means it has finished. You could zoom, okay, and you will see also the ligand, okay. This is the ligand. We have schist A, schist B, and then A, then B, then C, then D. Okay.
Okay.
Now we could import also. We could import the satellite image from here to import raster. We could import a new image here and just wait until it loads the raster image.
Yes, yes.
Okay. So let us now go to because just because our geophysical data here is not have the same georeference like this image. So I will go directly to importing the digital elevation model. So just right click on import digital elevation model and select load digital elevation model. Okay, now we select our topo.ask and click OK. Okay, now it has loaded. Okay, you see the loaded digital elevation model, right? Okay,
Yes.
okay, this is the loaded digital elevation model that we have imported. Now we are ready to create some modeling. You go to create 3D project and right click and initialize the project. Now you have to set your name of the project, for example, Enigma 2 or any name. And just you have to set the resolution of your model and the lithology column. You have to select whether lithology or veins. Here I select lithology and initialize the project. Now, after initializing the project, you could start modeling according to the sequence of your data. So we start by modeling erosion. The old erosion is schist, according to this data, is schist P. So we model the schist P. You see the contact surface for schist P here. Okay.
Yes.
Okay. Now you could model the younger erosion, which is schist A. Schist A in violet, but schist B in blue, right?
Yes.
Okay, you could change also the colors for any surface from here. Color surface, just click on color surface and select which one to change. For example, you would like to change the color for schist A and select red color and click OK. It will be turned into red, right? Okay.
Okay.
Now go
Okay.
to modeling the veins. The next event is the vein. We model the vein A. Okay, you could change the transparency. I will change the transparency for just to show the vein. Okay, and change the transparency for schist A also. You see now the vein?
Yes. Yes.
Okay, it is in
Yes.
violet color. Okay.
Okay.
Yeah.
Okay, now you could model the next vein. Vein B. It is in blue color. You see the intersection between the two veins, right?
Yes. Yes.
Yes.
Okay, and now model the third vein, vein C. It is in red.
Yeah.
And now going to the next vein, vein D. This is the last vein in orange, right?
Yeah.
Yes.
Now we model the erosion. We go to modeling erosion or cover. We select the cover. You see the cover or erosion surface above the vein.
Yeah.
Okay. You could change the cover from color. You could change it, for example, into white or any other color. Okay.
Oh.
And also show the other show schist P. Okay, and show schist A. Okay. Okay.
Okay.
Just you have to make it semi-transparent to show. Okay. Okay, and then you could build the volume. Now we have generated the volume, right? Okay.
Yes, yes.
Okay. Also, you have another options for building mesh surfaces or importing external mesh or editing mesh. And if you from the grid data, if you have if you have a grid data, you could also run the kriging algorithms and use statistical analysis and the block modeling. And also here you could edit the vein. I will edit the vein or make pinch out. It will make pinch out for all veins. Okay. Just from here, select apply pinch out to veins. It will make pinch out for all veins. Just wait because it takes some time and then it will apply the pinch out for all veins. Okay.
Okay.
Also, you have options to, if you have a fault, you have option to edit the fault or edit intrusion or edit fault. Okay. So this is a first overview of our software Enigma Geotrust. This is EnigmaQ Geotrust.